Hello and welcome to this video lecture on how to find area under a curve that is defined parametrically as in example 9. In this example, we need to find the exact area under the curve between the lines x equals to 4 and x equals to 16, which is shaded here. To do this, from earlier lectures, we know that the area is given by the integration of y dx from 4 to 16. Since x equals to 4t squared and y equals to t power 4 minus 4 ln t, we need to convert the integral to one that is in terms of t. We do that in 3 steps. Firstly, we need to change the limits of 4 and 16 to values of t. How do we change the limits of values of x of 4 and 16 to values of t? To illustrate this, let's consider the lower limit of x equals to 4. We are given that x equals to 4t squared in the question. So when x equals to 4, we obtain 4 equals to 4t squared. That gives us t squared equals to 1. Now we are also given that t is more than 0 in the question, so we know that t must be equals to 1. By similar working on x equals to 16, we will get t equals to 2. Secondly, we need to replace y to an expression in terms of t. Express y in terms of t. In the question, since y equals to t power 4 minus 4 ln t, we convert our y to this expression. Finally, in step 3, we change dx in the original integral to dx dt and integrate dx dt dt. Since x equals to 4t squared, we know that dx dt will be equals to 8t. So dx will have to be 8t dt. And we replace our integral dx with this 8t dt. Upon simplification, we find that we'll have to integrate 8t power 5 minus 32t ln t from limit 1 to 2. Now, how do we evaluate this integral? Split the integral into two different integrals. The very first integral can be easily simplified as this 8t power 6 over 6. We put in the limit from 1 to 2. Now the second integral, we will need to use integration by parts. Now since ln t cannot be integrated, we'll let it be u, and we'll let 32t be our dv dt. Recall integration by parts formula. When we integrate an expression that we have expressed as u dv dt, and we integrate with respect to t, we should be having uv minus integrate v multiplied to du dt, and we integrate the expression with respect to t. In our integral, our dv dt is 32t. So our v will have to be 16t squared. which is the integration, which is what we get when we integrate 32t. Our u is ln t, so our du dt will be 1 over t. Now substituting this into our integration by parts formula, we will have uv, which is 16t squared ln t. Put in the limits 1 to 2. Then we minus integration of v du dt. That is 16t squared for v, du dt of 1 over t. Now, since we are doing integration by parts with limits, we have to put in the limits here. When we simplify this, we will end up with 84, which came from our very first integral. And we will have 64 ln 2. This 64 ln 2 will come from the 16t squared ln t with limits 1 to 2. Now, these two negative signs will end up with a positive sign here. And when we cancel and simplify, and when we integrate, we will end up with integration of 16t that gives us 8t squared. We put in the limit from 1 to 2. When we simplify further here, we will end up with 24 here for 8t squared. Substituting it limits 1 to 2, that's give us 24. And when we simplify, we will end up with our final answer, 108 minus 64 ln 2. That's the end. Thank you for spending time to watch this video.